All right, we're looking at angles and polygons, and then we're going to look at fractional exponents. All right, so the sum of the measures of the angles in a triangle is 180 degrees. You knew that, right? Triangle angles always add up to 180 degrees. The sum of the interior angles of any polygon you can find using this formula. N minus 2 times 180. Any ideas what the N would stand for? Number of what? Of sides. The number of sides. So we want to find the sum of the interior angles of a pentagon. So 5 sides. Yep. So we're looking at 5 minus 2 times 180. You'll see how that works? And so we're really looking at 3 times 180, which equals 540 degrees. The sum of all of the interior. Like that's a 5-sided figure. This angle, that angle, that angle, that angle, and that angle all add up to 540 degrees. We don't know what they are, but add it all together, they equal 540. Not necessarily. It's a simple closed plane figure with at least 3 sides. I mean, sides don't cross, plane, it's flat, not like 3-dimensional. And closed, it isn't open. Closed. Okay? The sum of the exterior angles for every single polygon is 360 degrees. That's a hexagon. It's a regular hexagon. Draw regular figures for me. So you can do it with an irregular figure. All of these angles add up to 360 degrees. Okay? Yes. You could make it where it's not a regular polygon. It still looks like a windmill. It's not as pretty of a windmill because it's like odd shape. But all of those angles, this one, this one, this one, and that one, add up to 360. If you had a 20-sided figure, all of the exterior angles would add up to 360. There's one exterior angle at each person. Does that make sense? Right here. Does that make sense? Okay. So we want to find the value of x and y. What is this angle right here? Exterior, exterior, exterior. And what do we know about our exterior? They all add up to 360. So x plus 65 plus 50 plus 40 plus 8. All adds up to 360. Does that make sense? So 2x plus 20, 70, 72, 70. I think I get 290. Y'all see how that works? So now that we have x, can we find y? Y only occurs over here, right? So we're going to have to use something. Do you agree, Scott, that these are a straight line, so they have to add up to 180? Does that make sense? This looks like a right angle, right? Could you have assumed that it was? So just because it looks like a right angle doesn't mean it is. Any questions? Y'all see how that works? Okay, so what's the formula for the sum of the interior angles? N minus 2 times 180. What's the formula for exterior angles? It always equals 360. That is the formula, 360 degrees. Does that make sense? There's not really a formula. It's just they always equal 360. Okay. Inscribed quadrilateral. That means that the quadrilateral is inside of the circle. Do you see the picture, how the quadrilateral is inside of the circle? What? You can use more applications next year in geometry. This is a geometry topic. You'll see there are more applications. They do it more in geometry with applications. Some things that deal with math, are simply logic things, so that you can learn to think better and reason better. Usually, if you are better, like in geometry, you're better in reason. Really good at reasoning. It's the AC. The little box over there, it won't stop. So, if you have a quadrilateral inscribed inside of a circle, the sum of the measures of any pair of opposite angles equals 180. What angle is opposite angle A? So what do we know about A plus C? Equal 180 degrees. That's a triangle where you don't have one exactly across, but that's not a quadrilateral. So it's going to be the angle across. What about B and D? They equal 180. Does that make sense? Does that mean all four angles are congruent? Yes. Any quadrilateral angle, yeah. Any quadrilateral has sum of 180 times 2 for its interior angle. Okay, so we want to find x, y, and z. Is x 80? These angles, what do we know about them? Yeah, what do they do? So 80 plus x equals 180. So what does x have to equal? Does that make sense? What do you know about y? Y'all see how that works? How can we find z? Yep, it's this arc right here. So any ideas how we can find the arc? That inscribed angle is 80. So what does this whole arc have to be? Where did the 160 come from? If this inscribed angle is 80, the arc is 160. But z, is that 160? Z plus 50 gives you the 160. Because z and 50 make up the whole 160. Times 2? It's always times 2. You'll see how that works? So what would z have to be? You'll see how that works? I don't care. Sometimes I do, sometimes I don't. Sometimes they do, sometimes they don't. I haven't been able to figure out a rhyme or reason why they do that. Any questions here? Okay, let's look at fractional exponent. X to the 1 over n is the same thing as saying the nth root of x. You should not need a calculator for this. Do what? So how would I write x to the 1/2? Would it be this? Oh, that's what you just said. The square root of x. Do we have to put that little 2 there? Not when you're doing square root. It's understood. That's what the square root means. What would be x to the 1/3? The cube root of x. The cube root. Not the square root, the cube root. Yes. But you can't take the 1th root of anything. It's just the little number here. But when you're taking the square root, that's what square, 2. Square root, you don't have to put the 2. It's understood. The cube root. It's a completely different thing. It's actually the cube root of x. X to the 1/2 is the same thing as the square root of x. We'll get there. We do something with it, but we'll get there. Okay. So how would you write x to the 1/4? The not the square root. It's no longer square root. It's the 4th root. The 4th root of x. Does that make sense? What about x to the 1/10? The 10th, no cube. The 10th root of x. You see how that works? Okay. This, the cube root of 5, can be written as 5 to the 1/3. It's backwards, yeah. You're not going to, no, you wouldn't, we're going to do it again. So do you see where the cube root of 5 becomes 5 to the 1/3? The square root of 100, well, you know that's 10, right? But it's the same thing as 100 to the 1/2. On the radical. So square root, that's what it, like, that's what the symbol means, automatically, square root. Okay? You don't want to put it. It's not needed. Yeah, you don't want to put it there. So now instead of a 1, what do we have? An M. So the N still goes on the outside, but where did the M go? Over here. It's an exponent. You can write it either underneath the radical, like x to the M, or you can say the nth root of x, all of that raised to the M. Either one of them. You can either do it like that, or you can put it inside of the radical. You'll get the same thing either way. Doesn't. They mean the exact same thing. You can do it either way. If you look back, x to the 1 is just x. X to the 1 is just x. Okay. You can only do this as long as x is a positive number. So if you have this, you can't do that because negative 2 is not a positive. 5 to the 2/3. Which number goes with the radical? The 3. The cube root of 5 squared, or you can write the cube root of 5 squared. Yeah, but I mean, you want to see where the squared. They're just showing you how to rewrite it. We'll go over. They're just showing you where the 2 and the 3 go. But it just depends. It changes where you put the squared. So 100 to the 5 halves would be, where would that 5 go? On the end? Where would the 2 go? It's not there. Yeah. The square root of 100 to the 5th, or the square root of 100, all of that raised to the 5th. Okay? They mean the same thing. 100,000? We're going to get there. It's just talking how to write it, going back and forth. Okay, so we actually want to simplify this. Yes. 4 to the negative 1/2. No, the 4 is, if the 4 is negative. How do we get rid of negative exponents? Do you remember what we do? No. What do we do? So 4 to the 1/2. Now our exponent is positive. So 1 over the square root of 4 to the first power. What is the square root of 4? What is 2 to the first power? 2. Or what is 4 to the first power? And then take the square root. You still get 2. 4 to the negative 1/2 is 1/2. Y'all see how that works? Any questions? Any questions? Okay. We can do it. It's a negative inside of parentheses. If it was like this, you couldn't. But the negative, you ignore the negative until the end. Okay? So we're going to just look at 27 to the 1/3 for now. We're not going to look at the negative. We'll add it in later. How would I write 27 to the 1/3? No. The cube root of, do you need to put the 1? It's just to show you where it is. In case you don't. Any questions so far? What is the cube root of 27? So what is our actual answer? -3. Does that make sense? Because I took out the negative at the beginning. What? 3 times 3 times 3 is 27. When you take the square root, how many do you have to be able to pull them out? So when you're taking the cube root, you've got to have 3. Does that make sense? If you were taking the 10th root, how many would you have to have? Okay, they're not going to give you one like that. You took out 3 threes, and you put 1 on the outside. 1, 2, 3. Y'all see how that works? Okay, let's look at another example. If you're confused, I would be quiet and listen rather than talking. How would we start by rewriting this? Does that make sense? You could also write it like this. Does that make sense? Do you know 16 cubed off the top of your head? Do you know what the square root of 16 is? Instead of 16, I can say, instead of the square root of 16, 4, right? And then cube it. Does that make sense? That's where the notation changes. If you put it inside, you're supposed to say the 16 cubed and then take the square root of it. This way, it makes it a lot easier because you have smaller numbers. Yeah. You can do it either way. Y'all see how that works? So the 4 to the 3rd would be what? Which is 64. Yes. So we have 1/2 already. So um, they could be like the square root of 27. You can simplify that, right? Okay. That could be you wouldn't leave it as a square root of 27, but that could be something you did. Yeah. They're not always going to be whole numbers. So for this one, what do we ignore this negative? I'm going to put the negative up with the 1 so I don't forget it. Does that make sense? And make it 1 over what? 8 to the 2/3. You'll see how that works? The cube root of 8 squared. Do you want to square or take the cube root first? Do you know the cube root of 8? 2 times 2 times 2 is 8, right? Do you see how that works? The cube root of 8 is 2. And then square it. What would you get? there's a negative out here, when I made it 1 over 8 to the 2/3, I just put the negative up on top. Any questions on these? These you should not be using a calculator for. Okay? You need to be doing them out on paper, getting good at them. Because next year, and the next year, and the next year, they're going to get progressively harder, and you need to be able to do them in your head and not have to plug them into your calculator. No, they won't get big numbers. They'll just make it like the 5th root of 64 to the 3rd. Or the 5th root of 32 to the 3rd or something. So you do not need to be using your calculator for these. Otherwise, it's going to hurt you in pre-cal and calculus. Yeah. So you need to actually be getting comfortable with it. Plug it in. Raised to the 5th root, it's this little button here near where the square root is. It's like a little X. Okay. Any questions on these? Okay. Go ahead and clear your desk for your corrections.